All right, hello everyone. Welcome back to the Aptitude series. And today again we are going to discuss another important topic, which is your sequence and series. Okay. Now, if I talk about sequence and series with respect to the aptitude part, we really do not have weird series which are there like arithmetic or geometric progression, harmonic series, and all harmonic progressions and all. So the basic two series which are required for aptitude are arithmetic progression and geometric progression, right? So we'll be going deep into those kind of series and we'll see what kind of questions have been asked in GATE exam till now. All right. So my name is Karthik Karbanda. I'm from ISC Bangalore. And today in this, we will cover basically these four topics. Okay. This is the outline for the video. So AP series, GP series, then sum of infinite GP series. Okay. And the previous year GATE questions, of course. Okay. All right, so let's talk about now arithmetic progression, the AP series. Okay, so what is an AP series? See, I'll take some example to explain this. So let me take this series 1, 3, 5, 7, 9, and so on. Okay, now some series is given to you. Of course, if they mention a series, they will not say what kind of series are we looking at, right? So you have to identify that yourself, right? So to identify an AP series, it is very simple. The sum, the difference of the next term and its previous term should be constant. So if you see the difference over here is 2, the difference over here is 2, 5 minus 3, 7 minus 5, the difference is 2, and 9 minus 7, difference is 2. So the difference remains constant, okay? The difference remains constant. That is why we can say this particular series is in AP, okay? Is an arithmetic progression, okay? And now, once you know how to identify the series, you have to write two important terms, which are first is A and second is D. A is what? A is known as the first term, okay, and D is known as the common difference. All right. Now, if I talk about A, first term of the series, I'll just write first term of the series. So A will be what? A is equal to 1, okay, in this case. And in this case, D is what? Common difference. Common difference means the difference between second term and first term, the difference between third term and second term, and so on, okay. So this constant difference which is maintained in an AP series, this is known as your common difference. So D becomes 2 for this example, right? So these are the two values which are important, okay. Now we are going to see two important formulas. So for that, first thing I'll mention is an. What is an? Nth term of an APC. Okay, an represents the nth term of an AP series. Something like A10 represents the 10th term of the AP series. Okay, 10th term. All right. So what is the formula for an? An is equal to a plus n minus 1 into d. Okay. A you already know, d you already know. N is the number of terms. Okay. A you know, d you know, n is the number of terms. Right. Okay. This is one important formula, and the next formula is n by 2 2a plus n minus 1 into d. All right. So this is what Sn. I will just fine. So An is the nth term. Sn is the sum of first n terms. Okay, sum of first n terms of an AP series. I will just write it over here. Okay, Sn is sum of first n terms of the AP series. All right, this is what we mean by Sn. An is the nth term. Sn is the sum of first n terms. All right. Okay. So let's go back and let's see few things more in an AP series. Okay. So if I want to assume some AP series in general, an AP series can be assumed as this. First term is A, The next term, see, what you have to do is, if you are at the current term and if you want to find the next term, all you have to do is just add the d, the common difference, and you get the next term, right? So next term is a plus d. Next term is what? A plus 2d. Next term is what? A plus 3d, and so on. Okay. This is how in general you can assume an AP series in general. Okay. Now two more things are there. First thing is, if they ask you, assume three terms of an AP series. Assume three consecutive terms. Terms of an AP series. Your assumption would be A minus D, A, and A plus D. These are the three terms you are going to assume: A minus D, A, and A plus D. Alright. Another thing, if they say assume four consecutive terms of an AP series, then you will assume them as A minus 3D, A minus D, A plus D, and A plus 3D. Okay. So there is some idea behind these assumptions, why I took A minus D, A minus 3D, A minus D, and so on. Okay, there's some idea. So that is what we are not going to go in, because this video is mostly explaining you the concepts briefly, and then we move to the questions. All right. So there's some idea, so you can just keep this in mind. All right. Assume three consecutive terms of an AP series. Assume four consecutive terms of an AP series. All right. So this completes our discussion on AP series. Now, these are the basic things, very basic things, and this is what is required to solve mostly the problems which come. Okay. Many times they have actually combined a lot of concepts, like AP series and averages have been combined, and 1 mark question was given in GATE. Okay. Many times, other times they used to give applications on these series. Okay. So that's why basics are, this much basics are more than enough for you to solve the GATE problems. Okay. All right. So next we are going to see what? GP series. Okay. GP series. Now GP series is also known as geometric progression. Geometric progression. All right. So in GP series, what we have is, I'll take an example to explain it. Okay. Imagine I have a series like this. Okay. This is some series. Now, first is what? I'll try and calculate the difference and check if this is an AP series or not. If I calculate the difference, 3 minus 1 is equal to 2. Now, next difference is 9 minus 3 is equal to 6. Next difference is what? 27 minus 9 is equal to 18. Equal to 18, right? And so on. So if you see, the difference is 2, 6, 18, and so on. The difference is not constant. Alright? Difference is not constant. If I the series, okay. And what I do now is, instead of dividing second term with the first term, now I will divide them. Instead of subtracting, okay, second term and the first term, I will divide them. Okay, that means what I'm going to do is 3 divided by 1. Next is 9 divided. Next is 27 divided by 9. So what I'm doing is, next term and the previous term, I'm trying to divide them. Okay, and when you divide them, you get 3 over here. Result is 3. Here also it is 3. So see, when you divide these two terms, you're getting a constant value. Okay, you're getting 333 every time. This tells me that this particular series is in GP series. Okay, this particular series is a geometric progression, right? Okay, so this 3, what is this 3? This common thing which comes out, it is called as the common ratio. Okay, this is known as the common ratio. Okay, common ratio. And A is still the same what we discussed in AP series, that is the first term. Okay, first term. Now two things we want to find: what is the nth term and sum of first n terms, right? The same thing what we saw in AP series. So the nth term is equal to a into r raised to power n minus 1. Okay, that is your the nth term of the AP series. Nth term, sorry, GP of GP series. Alright, this is the formula, and n is again your number of terms. Right, n is again your number of terms. Now the Sn formula, Sn is equal to, now there are two formulas. I'll tell you the conditions for both of them. A into r raised to power n minus 1 by r minus 1. Okay, or the formula is, okay, just write it over here, or the formula is a into 1 minus r by n by 1 minus r. Okay, now you will be confused, sir, which formula to use. Okay, this the formula depends on, you actually can use any formula for any kind of n value. Okay, if you get negative term in the numerator, you will get negative term in the denominator as well. So those minus and minus will cancel out. Okay, and you will ultimately get your right answer. But it's actually better to use the formula correctly in one place. I mean if you're taking, if you have a series which has all the positive terms, so you should not get sum as a negative value, right? Whatever happens, sum should not be negative. Okay, so this case you will use when your r is greater than 1, or you will use when r is less than minus 1. Okay, r is greater than 1 or r is less than minus 1. This formula you're going to use when your r lies between minus 1 to 1. Okay, when r lies between minus 1 to 1. Now don't ask me, sir, what happens at r equal to 1 or minus 1. Basically, at r equal to 1 or minus 1, it's just the same numbers being repeated, right? 2 2 2 2 2 2 2, or 2 minus 2 2 minus 2 2 minus 2, and so on. Right, so this is what is happening. This formula is for this condition, and this formula is for this. So one more thing before I move to questions, one more thing in GP series we have to cover. Okay, so that is known as an infinite GP series. Okay, sum of an infinite GP series. So what that exactly is, let me take some series 1 3 3 square 3 cube and up till infinite. So what do I mean by infinite GP series? When the number of terms in that series are infinity, okay, or the last term in the series is infinity, then you say the sum of infinite GP series. Okay, so if I tell you find the sum of this series, so you know there are number of infinite number of terms over here. So you can tell me, sir, the last term will be infinity and the sum of infinite terms is equal to infinity only, right? The sum of infinite terms is infinity. Fine. So now let me take another series. So it will be 1 by 3, 1 by 3 square, 1 by 3 cube, and up to 20 terms. Okay, infinite terms. Now this sum, because the terms are decreasing, so this might give the sum might be some constant value. Okay, so how to find the sum? The sum for any infinite GP series is equal to a by 1 minus r. Okay, a by 1 minus r. And one thing we have to make sure is r lies between minus 1 to 1. Okay, r lies between minus 1 to 1. This is one thing we have to make sure, right? So when you find the sum, this sum will be equal to 1 by 1 minus 1 by 3. So that the sum would be what? 3 by 2 in this case. Alright. So this is the concept of an infinite GP series. This is the formula that you have to use. Okay. Based on this condition. If your R is greater than 1 or less than minus 1, you cannot use this formula. Okay. Alright. So this is mostly what I want to discuss about AP and GP series, which is there. Okay. Now let's move to some problems which have come in GATE. Okay. These are the problems which have come in GATE. Okay. So pause the video, try this problem yourself, and then unpause to check the solution. Okay. Alright. So I hope everyone tried the problem. Now let's see. They're saying find the least integer value of n for which the sum of this particular series, 3 plus 6 plus 9 up till n terms, is equal to what? 1000. Okay, is equal to what? 1000. So what we can do over here is, let's first try to find what kind of series is this. Okay, up till, so if I just take the difference of two terms, 3, and now I'm getting the same thing, so I can say that this is an AP series. Okay, A is what? 3. The common difference is also coming out to be 3. Okay, now they are saying the sum for least value of n for which the sum doesn't exceed 1000. Okay, so what I'll do is, I'll assume the sum equal to 1000. Okay, what I'll say is, I'll say Sn is equal to 1000. I'll say Sn is equal to 1000. So just want to find for what value of n it will give me exactly 1000. Okay, now I know that I'll not get n as an integer, but I'm good with that. Okay, just see what happens. So I'll just use the formula, 2a plus n minus 1 into d is equal to 1000. This n by 2 remains same. Now this is what? 6 plus 3d minus 3 is equal to 1000. Okay, now this you can actually try and cancel this out. So let's say this is 3d minus 3. So this is 3d plus 3, n by 2 into 3d plus 3 is equal to what? 1000. And you can take 3n by 2 common. So sorry, this will not be d, this will be n. Yeah, this is n. Okay, so I just multiplied it with d, na? So this will be n. N and 3 you can take common, you get n into n plus 1. Okay, 1000. So this gives me 3n square plus 3n is equal to 2000. Alright, now you have to try and find the value of n. The way you can do it, since this is a quadratic equation, it is not really difficult to solve it. Okay, n is equal to what? Minus 3 plus minus 3 plus minus under root of what? 9 plus of 4 into 3, that is 12 into 2, 24,000 by, okay, so you can say I don't need negative value of n. Okay, so I'll choose this guy with me. So I'll choose this guy. So that means finally I get minus 3 plus, if you just approximately calculate this value, na, I don't need the exact value because I know that n is not a complete integer. All right, just find the square root of 24,009. Okay, so this is coming out to be 154.95. Okay, by 6. So now that becomes 151.95. So we'll just see 151.95 divided by 6, right? So this becomes 25.325. Okay, so n is actually equal to 25.325. Okay, so I'll just show you some small thing. Okay, so let me try and find what is S25. Okay, so 25 by 2 into 2a. A is what? 3. So 6 plus 25 minus 1, 24 into d is what? 3. 24 into 3. So this becomes 72 plus 6, 81. So if you just try to cancel this out, 72 plus 6 is what? 78. I'm sorry, 78. All right. So this and this will cancel out, 39. So if you do 25 into 39, you're getting 975. That means 25, the first 25 terms is equal to 975. So if you just calculate the 26th term, that is what? 3 n minus 26 minus 1, 25 into d, which is 3. So 78. So if you add 78 to this guy, this will be what? More than 1000. Okay, more than 1000. So 25, sum of first 25 terms, 975. 26th term is 78. So it is more than 1000. Okay, now they are saying least integer value of n for which the sum exceeds 1000. So that means what? For 26, S25 was what? 975. S26 is what? 975 plus, which is more than 1000, right? So we can definitely say that n is equal to 26 is the least integer value for which the sum will exceed 1000. Okay, so n equal to 26 is the answer for this question. N is equal to 26. Okay, so this is the way in which this question has to be solved. All right. Okay, let's try now the next problem. Okay, fine. So pause the video and try the problem yourself. Alright, so I hope everyone tried the problem. Now let's see the solution. This is a very good problem which came in gate for 2 marks. Very good problem. Okay. Now S1 is the sum of an AP series of n odd number of terms. Okay. They are saying it is an AP series with n odd number of terms. N odd number of terms. Okay. So let me just define this AP series. Okay. Let me take the general way what I did. Okay. So it is what? A, then a plus what? Odd number of terms, right? So a plus d, then a plus 2d up till finally c. Finally, we have n number of terms, but n is odd. Okay, that means a plus n minus 1 into d. This is my last term, a plus n minus 1 into d. Now, if I consider S2, S2 be the sum of the terms of series in odd place of the same series. Okay, now this is important. Odd place of the same series. So this is first place, in this is second place, this is third place. Okay, then fourth and then fifth place and so on. So what they're saying is S2 series is actually formed using taking the terms from the series in S1. Okay, but only the terms which are at odd places. So that means I'll take A, then I'll take A plus 2D, then I'll take A plus 4D, okay, and so on. Now the question is what? The last term, where will that lie? Okay. Now see, I was saying na, this n odd number of terms. Odd number of term means you're starting with 1, 2, 3, 4, 5, and you will end at what? An odd number. Odd number. Okay. So whatever this term is, it is an odd number. Okay. The position of this term is at an odd number. Okay. So I can safely say that this term will also be a part of the series. Okay, so the last term for this series is also this. But the difference is in S1 the number of terms are n. Okay, number of terms are n, while in S2 I don't know the number of terms because we have only selected some terms, so we'll have to calculate that a bit. Okay, so fine. Now when I talk about sum, okay, I have the first term, I have the last term. All I need is the number of terms. So let me find the number of terms in S2. Okay. So see, I have the nth term with me. So nth term is equal to this. And the formula for nth term is what? A plus number of terms, let's say L. Okay, for the series S2, let's say L. L minus 1 into D. Alright. So A and the series first term is also this, okay, plus n minus 1 into D. Now D is what? See, 2D is there. Okay, the difference in this series is what? 2D, 2D, 2D and so on. So your common difference is 2D now. A and A will cancel. You get n minus 1 into D is equal to L minus 1 into 2D. D and D will also cancel. So you get n minus 1 is equal to 2L minus 2. And you get your L as what? So L will be n plus 1 by 2. Okay. So number of terms in second series is what? N plus 1 by 2. Okay. We have found this. Now it becomes really simple. All I have to do is find S1 by S2. Okay. So I'll write S1. S1 is what? Number of terms are capital N by 2 into. So the another formula for sum that I did not mention in theory, but it is useful over here. So the formula is n by 2, number of terms divided by 2 into first term plus last term. Okay. If you have the first term and the last term, you can use this formula. Okay. the number of terms divided by 2 into first term plus last term. All right, so first term is A, last term is this. So A plus n minus 1 into D. Okay, divided by now n plus 1 by 2. Right, we got n plus 1 by 2 and again by 2. Right, so this is your n. Basically L by 2 we had written. No? Okay, so this will be what? First term plus last term. See, first term plus A plus n minus 1 into D, last term. So the logic over here is, see, first term and last term for both the series are coming out to be same. So you can just cancel this part. Okay. So the calculation is saved by, lot. So n by 2 into this comes up and this becomes 4 by n plus 1. Alright. This and this will cancel. So you get 2n by n plus 1. This is the answer. S1 is to S2 is equal to 2n by n plus 1. This is the answer. This was a GATE question, came for 2 marks. A very good question. Alright. Okay, so I hope everyone understood the problem and the solution. Let's check the next problem. Okay. Now they are saying what will be the maximum sum for this series. This sum series is given to you. I want to find what is the maximum sum for this series. Okay. So pause the video and try to solve this now. Alright, so I hope everyone pause the video and try to solve the problem. Okay, so let's check out the solution. So now I'll just write the series. Okay, now see, in this series, first I have to identify whether this is an AP series or a GP series. So if I take the difference, okay, the difference is all 42 minus 44, which is minus 2. 40 minus 42, which is minus 2, and so on. Okay. And you, when I explain that we have, common difference and all things, common difference can be a positive value, common difference can be a negative value as well. Okay, it can be anything. So constant and it is minus 2, so we can say that definitely this series is a P series. Okay, now to understand the question, what will be the maximum sum? So 44 then this, and you see that this is a decreasing AP series, right? So eventually what will happen is it will cross the zero value and go to the negative side. So we don't want to go to the negative side. The reason is that will actually reduce your sum. Okay. So if you include terms which are negative, that will reduce your sum, right? So we want only positive terms in the series. Okay. So if I write this series 42, 40, then 38, then 36, then 34, and so on, you will see that you are getting even terms and it will go till 2 and 0. Okay, so either you can find some second 2 value or 0, both of them will give you the same result. Okay, because adding 0 to a sum will not change it, correct? So let me find till 0. Okay, so I'm saying first I need to find what is the 0th term. So 0 an I'm using the formula. Okay, an is equal to a plus n minus 1 into d, right? So an is equal to 0, a is what? 44, n I don't know, I need that, and d is minus 2. So this becomes minus 44 is equal to minus 2 into n minus 1. So this will cancel out, this becomes 22, n becomes 23. So A23 is coming out to be 0. A23 is coming out to be 0. Alright. Now I need what? I need to find the sum till this term. Okay. I need to find S23. S23 is equal to what? 23 by 2 into. So I have the first term and the last term with me now. So this makes my life easy. Okay. First term is 44, last term is 0. So I'll just put the value. This becomes 23 by 2 into 44 by 2, and then this will cancel. So let's see what is this value. 23 into 22 becomes 506. Okay, so 506 is the right answer in this question. Okay, if you would have calculated S22 also, that also would have yielded 506. Okay, you can try this yourself, that will also yield 506. Okay, so I hope this problem was also clear to everyone. Let's move to the last problem for the video. Okay, right, now this is again a different kind of problem in which you were actually required to use sequence and series concepts. Okay, so I'll let you try this once. I'll just read the question for your comfortability and then you can try. One side of an equilateral triangle is a centimeter. The midpoints of its side, a is a constant. Okay, a centimeter is the length of the side. The midpoint of its side are joined in such a way that the midpoints become the vertices of another triangle. Another, again, the midpoints of the new triangle are joined to form another triangle. This process continues till infinity. So you have to find the perimeter of all the triangles. Okay. Now go ahead and try the problem. Okay. So I hope everyone tried the problem and maybe got the solution as well. Okay. So let's see the question now. So this question is more of a visualization thing. You have to spend little time trying to understand what it is saying. Okay. The calculation part is easy, but understanding will take little time. Okay. So that is where we can spend. We don't have any problem spending some time over here. They are saying one side of an equilateral triangle is a centimeter. Okay, this is a, this is a, and this is a. You know, it's an equilateral triangle, so all sides will be of the same length. Midpoint of its sides are joined in such a way so that it becomes the vertices of another triangle. That means these midpoints are joined in such a way that they become another triangle. All right. So now see, this is a midpoint, right? So this length becomes a by 2. This is a midpoint, so this length also becomes a by 2. All right. Now the question is, what is the length of this triangle? Because we need to find perimeters of all the triangles, right? So if you see, the length of this triangle will be what? See, this is a by 2, this is a by 2, and this angle is 60 degree because the bigger triangle is an equilateral triangle, right? Now this is a by 2, this is a by 2. So these two angles are also same. Since this is 60, this is also 60, and this is also 60. That means that since all the angles are 60, these smaller angles which are being formed, these are also equilateral triangles, right? So this length is equal to a by 2. Okay, the one side, this side of the smaller triangle is also a by 2. Now similarly, you can prove that these two are also a by 2. Okay, so what I'm trying to say is, this will give you, when you form, take the midpoints of a bigger triangle and form the smaller triangle, the length of this will be halved. Okay, previously it was a, so now it is a by 2. Okay, so I'll just write the lengths of the triangles. So first triangle length is what? A. Second triangle which is being formed, length is what? A by 2. Third triangle which will be formed will be what? A by 2 square. Okay, halved of it. Fourth triangle will be what? A by 2 cube, and so on. So this process continues up till infinity, right? Now my job is what? To find the sum of this. To find the sum of this. Okay. Now see, I'll just try and write first the sum of all the first triangle. So we have three sides, each of length a. So the perimeter is 3a. Second is what? 3a, a by 2 plus a by 2 plus a by 2. That is 3a by 2. 3a by 2 square. Next is 3a by 2 cube, and so on up till infinity. This is going till infinity. Now see, I have 3a common in them, so I'll just take 3a common. Okay, this becomes 1 by 2 plus 1 by 2 square plus 1 by 2 cube up till infinity. All right. So if you observe this, this is what? This is a GP series with infinite terms. Okay. So let's try and use the formula. The formula was a upon 1 minus r. Okay. R is what? 1 by 2 over here. So a is what? 1 and 1 by 2. Right. So this gives you 3a into 1 minus is half, 2 comes up, this becomes 6a. Okay. So perimeter of all the triangles in this given problem is nothing but 6a. All right, people. So I hope everything in this video was clear to you. Okay. If you have any comments, please mention them in the comment section. And if you like the video, please do not forget to share it and subscribe to our channel for more videos. Okay. Until then, I'll see you in next couple of videos. All right. Thank you, everyone.